Go. Hello, how we doing? What are we doing today? How do you use the chain rule? But you know this already, don't you? No. Really, you sure? No. All right, well, let me ask you this. Do you know what the derivative of x squared is? 2x. 2x, right? Do you know what the derivative of x cubed is? Yes. 3x squared. Don't look so excited. Right? Okay, well, what if... Let's see. Let's ask Cass TL to wake up. Let's make a calculator page. What if I do quantity? No, wait. Hold on. Wait a minute. Wait. Menu, calculus, derivative. There you go. With respect to x, of the quantity, it died already. Look at that. Are you kidding me? You know? Okay. And of the quantity x. Instead of x squared, x plus 1 squared. And we get sort of like 2x, right? If it was x squared, we get 2x. If it's x plus 1 squared, we get 2 times x plus 1? So the power rule just works like that, right? No? You sure about that?
Yes.
How about if we do x cubed? Let's get back over here. Huh. So it's like 3x squared, right? No? It's not?
The derivative of the inside is
Yeah, that's just
Oh.
Yeah.
Oh, that was too easy. Okay. Let's change it a little bit. How about if I make it... How about I put a, I don't know, 2x? Ooh. Ah. What's going on? You got to multiply with the derivative of the inside. Oh, okay. How about trig? No. Stop that. Stop that. How about menu? Calculus. Derivative function with respect to x of... Let's see. How about sine of... Oh, I don't know. X squared. Okay. All right, so predict then. Derivative of sine is usually... Cosine, but it's going to be 2x times that? Oh.
2x cosine x.
Wow, interesting. All right, so what if I change that to, can I change this easily to cosine?
just type it.
Yeah, I know, but I'm being lazy
I'm being lazy.
on purpose, just to see if this works. Oh, see what it did to me?
You can just delete.
Yeah, I know, okay. All right, and you know, let's be really crazy. Oh my God. All right, predict. Derivative of cosine is usually negative sine, but it's going to be negative sine of x cubed times 3x squared. Oh, you're too good at this. OMG. All right. So what if I put tan in here, huh? Let's put tan in here. Okay, so ding, ding. I probably should just type it, right? All right, tan. Where are you? T-A-N open. All righty. Oh, let's live la vida loca. Are you ready? Boom. All right, predict.
4x cubed secant squared.
4x cubed secant squared of
X
the stuff. Well, is that the same? Yeah, I guess so. Oh, why did it do that? Oh gosh, I forget now. Yeah, there's a reason for that. Yeah, if you had the handheld, you could click on that with your handheld mouse. You know you have a handheld mouse, right?
Yeah.
If you like move your mouse, your finger around here, there's a real mouse that shows up. My PC mouse doesn't work the way that mouse, so you can do that. Okay. Alrighty, so riddle me this. There we go. What if y is 9x squared plus 6x plus 1? What's dy dx? 18x plus 6, right? But isn't that factorable?
Yes.
Isn't that a perfect square factor?
Yeah, 3x plus 1 squared.
3x plus 1 squared. All right, now use the chain rule. So what does the chain rule say about that? Stuff squared. What do you get?
6x times
2 stuff to the 1 times the derivative of the stuff. And 2 times 3 is 6. And 6 distributed over 3x plus 1 is 18x plus 6. Same thing, right? But sometimes you don't have 2 ways to do this. What's nice about the chain rule is now you can combine all your rules together. Any composed function. All right? So what are we saying? If h of x is a composition of f with g, what's h prime of x with respect to x? What would you say?
Half G prime
The derivative of the outside composed with the inside
times G.
times the derivative of the inside. Okay. So we have a song for this. Lights, camera, and action.
Don't change it.
Okay, do you know the song?
Wait, that's the derivative of...
That's the derivative of f of g. F prime of g times g prime. All right, let's see if that's true according to the internet. All right.
Lazy stuff.
Hey, I really wanna do calculus. Very much like to derive. Don't feel like making a mistake. I'll use chain rule for my own sake. Today I swear I'm gonna do
All right,
calculus.
some chain rule problems.
To differentiate sign, just switch rule from x, go the other way. You don't even gotta flex. Just throw on the negative. I'll be sitting in my seat, 100e to the x, laughing at my error. It is
Did
too
you know the derivative of e
complex.
to the x?
'Cause in
Yeah,
calc,
talk
it's
about
the
that,
same
Jen.
freaking thing.
Talk about that.
Oh, I answered, derived it, aced it 'cause I'm smart. Today I really wanna do
Right, is that
calculus.
Not chain rule.
Very much
Is that
like
correct?
to
Eat of the
derive.
If you eat the stuff, then derivative of the stuff.
Feel
Yeah.
like making a mistake. I'll use chain rule for my own sake. Today I swear I'm gonna do calculus. Calculus time. Whoa,
Yeah, that's a normal
whoa, oh, oh. Calculus time. Whoa, whoa, oh, oh. Questioning me about the natural log. It's a really easy task. Don't need a guide dog. Just gonna scream out 1 over x. Oh my god, 1 over x. I might mess around and do Taylor series. I bet Info would be so proud of me. Sorry, Derek, you'll just have to
Whoever Derek is,
wait.
it's between inside and Eric.
Oh, I answered, derived it, aced it 'cause I'm smart. Today I really wanna do
Alright, is that
calculus.
Not in the chain rule.
Very much like to
Derivative of
derive.
It's one of the
Feel
stuff
like
that's derivative
making
of stuff.
a mistake. I'll use chain rule
Because then it
for my
stops.
own sake.
It's the
Today I
derivative, it's
swear
negative.
I'm
Times
gonna
stuff
do
times derivative of stuff.
calculus.
Yeah.
Now you better not be a fool. Don't forget to use chain rule. No, 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 no. When you derive x to the end, just have the minus n.
And
Yeah,
X
yeah,
minus
yeah,
one,
yeah,
right?
yeah, 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 yeah. Oh, today I really wanna do calculus.
That's just power rule.
I very much like to derive.
Eat of the stuff, you get eat of the stuff.
Feel
then
like
derivative of
making
stuff.
a mistake. I'll use
Cosine
chain
of
rule
stuff,
for
you get
my
sine
own
of stuff,
sake.
then derivative of
Today
stuff.
I swear I'm gonna do calculus. Calculus time. Whoa, whoa, oh, oh. Calculus time. Whoa, whoa, oh. Calculus time.
That was hard.
Can you
Alright.
explain that clock?
When
Let's see if we
Explain
can
the clock.
Well, that can explain the clock.
Yeah.
right.
Clock? Not right now.
Like making a rule for my own sake. Today I swear.
Alright, let's check his work. Alrighty. Let's see here. Alright, I'm just going to check the chain rule problem. So it's e to the x cubed. It's negative 2 cosine of 6x squared. And what is it? Sine of e to the x to the fourth. All right, let's try these on our own, see if we get the same answer.
Is that a double chain rule?
Yeah, the last one. That's why it's called the chain. Sometimes you have to do it more than once. Chain on chain on chain on chain. Okay. Alrighty. So let's check his work. Let's see if Bruno's good at this. Alright, we need the front two lights, please. Okay. Alright, so what's dy dx?
There's no front two.
3x squared e cubed.
Now, remember we said, now we haven't proven this yet, we will, that the derivative of e to the x is itself, right?
Yes.
So now all you have to worry about is the derivative of e to the x is itself, and the derivative of x cubed is
3x squared.
3x squared. That's all you need to know. How do you do the derivative of e to the stuff? The inner function is the stuff. I'm plugging that into the e to the, what you're plugging in, right? So you get e to the stuff times the derivative of the stuff, right? That's it. Okay. Let's see. What was this other one? What if y is negative 2 cosine of 6x squared? How to get dy dx? Well, you know the derivative of cosine x? Negative sine. You know the derivative of 6x squared?
That's negative cosine.
Oh, negative, right, negative. The derivative of cosine of x is negative sine x. And derivative of 6x squared is 12x. So what's the derivative of cosine of stuff?
Isn't this the product?
Negative sine of stuff, right? So the negative in front goes away? Times the derivative of the stuff. You said this is 12x, but there's a 2 in front, 24x.
Wait, so did you technically just do the product rule, but since one
It's not a product rule.
but
It's
negative 2 times cosine 6?
well, yeah, but we're not doing product rule there. You could do product rule there, but it's a lot of work for nothing. Remember, we said that the derivative of a constant times a function is simply the derivative of the function times a constant. You don't have to do the product rule. If it's just a number,
So it is the product rule.
It is- you could-
Except because it's a 0.
yeah, you're right. It zeroes out, so I'm not doing it that way. Alrighty, and you also had this one. Let's see, y equals sine of.
E to the
I can't write. Stop it. Sine of e to the x to the fourth. Okay. So what's dy dx? All right. So who's the inner function? E to the x to the fourth. That's being plugged into sine. So who's the outer function? The derivative of sine of x is usually cosine x. Derivative of e to the x to the fourth. Well, wait a minute. Isn't that another chain? How do you do the derivative of e to the x? E to the x. How do you do the derivative of x to the fourth? 4x cubed. So how do you do the derivative of e to the stuff? E to the stuff times. All right. So the derivative of sine of stuff is cosine of stuff times the derivative of the stuff. What's the derivative of e to the x to the fourth? Well, that's e to the x to the fourth times the derivative of x to the fourth. And it's a product. You can write it in any order you feel like it's a free country. Yeah. Okay. How do you do the derivative of sine of stuff? You do the cosine of stuff times the derivative of the stuff. Right? What's the derivative of the stuff? Well, it has its own stuff, inner function. So what's the derivative of e to the stuff? It's e to the stuff, because the derivative of the e to the x is just e to the x, times the derivative of that stuff. It's a double chain, yeah. Yeah, that's why it's called the chain. Sometimes it chains. That's why it's called the chain rule. Okay. Alrighty. Why don't we check some more?
But you can't put those together, right?
Well, it's a product. You can put it in front. I think that's probably how we wrote it.
Yeah.
Using e to
Let's see, how do you write it? Did you write 4x cubed, e to the x to the fourth, then cosine?
Yeah, I think so.
Yep. There you go. And that we got the 24x, right?
That's not e.
Huh?
It's not. It's definitely
Well, let's do it up.
It's the only one that's still.
Hang on. Let's check some more of Bruno Mars's work. All right.
I'm not tired of it. When it starts to frustrate me, I'll get tired.
That's the end of the formula.
I know.
All right, I'm going to do ln of sine and cosine of ln. Okay.
Ellen is hard.
Hola. EU. How to spell in German? German?
Yeah.
Gotta practice your dictas. Herr Leonhard Euler, das Professor, Doktor. All right, so here we go. Let's try this again. What if f of x is ln of sine x? Fun secret facts that they told you the derivative of ln x, 1 over x. Okay. So what's the derivative of ln stuff? 1 over the stuff. Okay, so f prime among friends with respect to x is 1 over stuff times the derivative of that stuff. What's the derivative of the cosine? So sine.
You wrote sine, yes, cosine.
Sine. What? What's the derivative of sine? It's the cosine. But cosine over sine is also known as cotan. Cosine over sine is the answer, but you could write it this way. All right, Bruno. Right? Okay. That's it.
It's not actually Bruno. It's Brewer 1-3.
What?
Yeah, I don't know who the hell it is. What?
You had like more than just sine x there to all go on the bottom, then you'd have to do another chain row for whatever reason.
Right, yeah.
Wait, Mr. D, can you explain that again?
No, I
Why
can't.
is it
What?
sine over sine?
Okay, let's do it again. All right. The derivative of ln of u is 1 over u du dx. Okay?
Yes.
Yeah, I think your book writes it that way, right? What if you have, well, I'm not going to rewrite it that way, but I think your book uses the inner function, they call it u. Okay.
Yeah, you saw,
So that when we get to u sub, it's just changeable backwards, right? All right, try this.
I hate you subs.
You know, u sub hates you, so it's okay. All right, so
Alright, that
g
was
of x.
Not cause for a reaction.
All right, so who's the inner function? You know that when I say mother function, I talk about the mother function dance and all the functions you're supposed to know how to graph. Actually, mother function actually came from this. The mother function is cosine. The outside function. That's actually where it came from. I stole it. Remember we talked about Mr. Che? He called the outside function in chain rule the mother function. I stole it and made it the functions you're supposed to be able to know how to graph, right? So the derivative of the cosine? Negative sine. Derivative of ln? 1 over. So g prime with respect to x is negative sine of stuff times the derivative of stuff. Are we okay with this? Yeah, what? You could. Yeah, that's how you put that out. Yeah. Well, we'll prove that. See why. Okay. Okay. So, let's see. What did Bruno say about that one? Negative sine ln x over x. That's what we got?
That's technically like it's over x because you timed it by the
Because
derivative.
yeah, technically, oh, Garcia, you got to stop doing that. 2 steps in one, you silly person, you. Yeah, okay. But this is just a fraction. And how do you multiply fractions? Numerator times numerator. Denominator times denominator. Okay. I'm sorry. Okay, so let's check some more, Bruno. Come on, Bruno. He had another one, right?
We did this exact lesson last year. We checked this video.
Let's see.
So you know it's true already.
In every video, he seems to find something.
Up to there.
What's wrong with it? What did he do wrong?
All right, let's write this down. So e to the sine x, so just doing the chain rule stuff. Sine of e to the 2x and e to the 3 cosine of 4x. Okay. Let's check all of this work. Let's see if Bruno got 100 on his quizzy. You want to do the bottom? Wait, we got to warm ourselves up. No, we got to warm up to that, man. Alrighty. Y, wake up. Y is, what do they want? E to the sine x. So who's u? Who's the inner function? Who's the stuff? Sine x. Derivative of the sine x is cosine x. What about the other outer function? How do you differentiate e to the x? E to the x. So dy dx is going to be what? E to the stuff.
E to sine x times cosine.
times the derivative of the stuff.
But why is it? Well, because the stuff in E is considered what's in the.
It's what you're plugging into e to the x.
Well, e to the x is
The inner function is what you're plugging into the other function.
So
I'm plugging sine x into e to the x. I'm not plugging e to the x into sine x, right? Yeah.
Wait, there's no derivative for e to the x, it's just e to the x.
Well, yeah, it's e to the x.
are we gonna prove this?
Can we just have
E to the x is the only function that's its own derivative except for, I guess, 0.
I
Okay.
feel like we proved that last year. but I
Okay.
don't remember why.
And we're gonna prove that too. So, yeah, it was secret fun fact. What was the secret fun fact last week? When before I died? Oh, Wednesday.
When you died?
Yeah.
You died
This is
yesterday?
AG. We're past the right? BG and AG? No. No. Then we talk about secret fun fact. When you go to the Museum of Natural History, you don't have to
Oh, yeah.
pay, right? Secret fun fact. Okay.
Oh, yeah.
Secret fun fact he threw in here was the derivative of e to the x is itself, and the derivative of ln of x is 1 over x. That's secret fun fact because we didn't prove that yet, but okay.
We also didn't prove that you don't have to pay at a museum yet.
And well, I proved that Saturday. I tested it out. I had an experiment. I had a
that
dollar
before,
bill. Well, you pay $1. You pay in your heart of hearts. How much do you want to
It's
do?
all of the ones that are funded.
Well, they have
by
this new
websites.
thing now that the entry fee is like $22, suggested entry. But if you want to go watch the IMAX, it's another $5, another
yeah.
$4, so it's $26. Wow! But if you're just going to walk around the established
Museum.
stuff, exhibits, right? Not the special shows or whatever it is. You don't have to pay more than what you want. All right? But if you're going to a show, you got to do the $26. Anyway, so here we go. Y is the sine of stuff, but this is e to the stuff. Oh God. All right, watch it, careful, danger, Will Robinson.
Cosine.
The derivative of sine of stuff. Cosine of the stuff times the derivative of the stuff, but the stuff has its own stuff. So what's the derivative of e to the stuff? E to the stuff times the derivative of that stuff is 2. Okay. All right, so you good at this? It's a product. You know the associative property of multiplication. The order doesn't matter. What did Bruno say?
I even got a new colored pen.
2 e to the 2x cosine e to the 2x. 2 e to the 2x cosine e to the 2. Yeah, amazing.
It's light
Okay.
blue lit.
And how about this one? Y is e to the 3 cosine 4x. Okay, so dy dx is going to be, how do you differentiate e to the stuff? E to the stuff times the derivative of that stuff. How do you differentiate 3 cosine 4x?
Oh no, it's got its own stuff.
It's got its own stuff. I know. So much stuff. All right, so what's the derivative of cosine 4x? Negative sine of stuff times the derivative of the stuff, which is 4, but you had a 3 in front, so how about we say 12?
4 more years.
Alrighty. And did we do all the stuffs? I think we did all the stuffs. So negative 12 sine 4x, what do you write? Negative 12 sine 4x, e to the 3 cosine 4x, e to the 3 cosine 4x. Amazing. Amazing. Well, it's nice because now you can combine all your rules that
So
you
what
know.
is that? Negative 12?
Negative 12, yeah.
It looks like a 1.
I know, everybody's a critic.
A 1 liter.
Yeah, I know. Let's see, what else is good here?
Alright, what's the longest function you can do? That we
Well,
Wait, can you create a function with E, ln, and cosine in it?
oh, you could do all kinds of crazy stuff. You really want to go that
Come on,
nuts?
let's do chain rule like
Ah. All right,
I'm
let me-
ready.
let me just show you a question that apparently was impossible. Now, this was 88 AB1.
AB1.
1 is supposed to be easy, right? AB, come on. We're beyond that, right? Come on. What is AB? And 1? Okay. Somewhere in 88 AB1, you had to differentiate this function. And so many people got this wrong.
Just write it as one hand.
It was something about finding the tangent line at x equals 5 for this function. Something like that, right? So you need the derivative of 5, right? So how do you get the derivative f prime of x? Chain rule, because you're going to write this how? Stuff to the 1/2, right?
Instead of u substitution, we should do stuff substitution.
Well, yeah, u substitution is coming in several months. All right, so the derivative of f with respect to x is, well, now who's the inner function now? Right, so we plugged in x to the 4th minus 16x squared into the radical function, right? So stuff to the 1/2. How do you do that? That's power rule. So what do you do? 1/2 stuff to the negative 1/2, right? Because you bring down the x1, then you subtract 1 from the x1, 1 from a half is negative, okay? Times the derivative of the inner function is 4x cubed minus 32x. What if you wanted to write that without negative exponents?
Well, it'd be impossible to plug
It's
that in.
impossible, right? No. Yeah, it's really, who's the numerator? Who's in the numerator? 4x cubed minus 32x. Who's in the denominator? 2 times x to the 4th minus 16x squared to the 1/2, right? With a negative exponent in the numerator, it's a positive exponent in the denominator, and vice versa. Negative exponents do not mean negative numbers. They mean reciprocals. And what if you wanted to go back into radical form like you started? It's going to be radical x to the 4th minus 16x squared on the bottom. What about the 2?
Can you actually?
Can't you reduce? And you get? 8, really? Oh, God.
But can you?
2x cubed
The
minus?
square root of the bottom of that.
Is that a perfect square?
Isn't it x squared?
No, it's not a perfect square, I don't think.
Why not?
Because it's not factored. If you to be able to square root it, you have to be able to factor it such that both factors are the same. Is that what you're getting here? No, it's dots, isn't it? Dots. Differences to squares. If you factor it, you don't get two factors that are the same, so you can't square root it. Yeah.
Are we allowed to leave that radical at the bottom?
Why not? Oh, Hypatia, I know.
What's Hypatia?
Did we talk about Hypatia? No. We didn't talk about Hypatia. We did, right? Yeah, under time constraints on the AP exam, you don't have to rationalize. And you don't have to even reduce. Okay, as long as it's correct, otherwise. Or unless you need to later on to make stuff easy, maybe it's in part, this is like part B. In part C, if you needed to use that, and it was helpful to rationalize it or simplify it or something, that's up to you. Right? Alrighty, so 88 AB1 was so hard. And then of course you can plug in 5. By the way, 88 AB1. We had bear skins and stone knives in 1988. What are we talking about? No calculators. So this
That
can't
would
be
be
impossible.
really hard.
Plug in 5. Are you nuts? What?
Multiply
5 times 5 times 5. Thank you. 5 times 16?
80.
Right. 5 times 5 times 5. We already got
That would take
125 times 5. 625.
Not all
Use
of us are
paper.
doing calculators.
Use pencil and paper.
Yeah, but
It's not that hard. Guys, you got to know your stuff. Look, I always tell the counselors, don't you dare put nobody in pre-calc who doesn't know how to add, subtract, multiply, and divide signed numbers, rational numbers, and their decimal equivalents.
What?
And signed numbers, integers, like 2,
Oh.
negative 5,
I thought
rational
you
numbers
like
like
take the sign
fractions,
of
2
any
fifths,
number.
negative 5
Take
fourths,
the
right?
sign of
And their decimal equivalents, 0.8, 1.2, right? And don't you dare put anybody into calculus who can't do the same thing with rational functions. Rational functions. Functions made out of fractions made of functions, okay? All right, so don't forget your homework tonight. Whoops, where did it go? There it is. Bing, page 158, multiple 5 chain rule. Practice. All right, you two. Thanks for coming. Bye.